Okay. Okie doke. Welcome to Dev Delta. What class is this? We are on class lesson 11. Awesome. And we are talking about looping and iteration. So last week we talked about arrays and how we can store data, multiple pieces of data into containers and move those around and put them in memory, kind of contained as a group. And today we're going to talk about looping and iteration. And these two things work together really well. So loops and arrays are really made for each other. They're a match made in heaven. So a loop is a JS piece of code that runs over and over again, stopping only when you tell it to. You will often see loops used with arrays. Whenever you have a repetitive task to complete, you'll probably want to reach for a loop. Today we'll be talking about the for loop. There are other types of loops, but for starters, the for loop is going to be the only thing you're really going to reach for quite a while. There's a loop called a while loop that's also very common. But the syntax to that is kind of similar. And once you understand the for loop, the while loop will be really easy to pick up. So today we're just talking about the for loop. Why do we need loops at all? Loops allow for rapidly completing repetitive tasks, and they allow your code to be more dynamic and flexible. So let's say, for example, if you had to print out the numbers 1 through 100 in a console, you could do that with the code we've learned so far. You could just say console log 1, console log 2, console log 3, console log 4. And that's going to take a long time for you to actually write out all this code. And it's not something that can change. You couldn't change that to console log, the numbers 1 through 200 in the console quickly. You'd have to keep writing all these numbers. So this is not a sustainable way to do something very repetitive. So you might be thinking at the end of this, there's got to be a better way to do this. Hallelujah for the for loop. So this code here will do the same exact thing that 100 lines of this would do. And this is kind of a contrived example of the power of looping, is that it allows us to just do things instantaneously that are very powerful and would take a really, really long time to do by hand. So for following along for this lesson, we're just going to do this in the console itself within the browser. So go ahead and hit Command Option J to open up your dev tools. And you can type clear. If there's any errors in there, sometimes it just comes from the browser. You can type clear. I guess that's a function, sorry. Clear, and that should clear everything. Or you can hit Command K, that will also clear. Cool. And right click inspect is also a way you can open up your console. So in the console here, let's just copy and paste this in if you have the lesson plan open. Colin, do you have the lesson plan open?
I do, yes.
Just unmute yourself. Sweet. Okay, cool. So we'll copy and paste this in here, and you can actually just run these things directly in the console. You don't have to do it specifically in a snippets file, and you don't have to do it in your own external JS file. You can just do it right here. Any JavaScript will run in the console. So we dropped that in and we ran it, and instantly we see 1 all the way down through 100 printed out, which is pretty cool. And that took very little effort to do that. Okay, so let's talk about the syntax and the terminology of what we just pasted in here. So for loops are made up of an initializer, a condition, and a final expression. And I'm actually going to zoom in here a little bit so we can take a better look at this. Okay. So yeah, so they're made up of an initializer, a condition, and a final expression. The curly braces hold the code that will be run as many times as the loop iterates. So this chunk here holds the code that will actually run. This right here is our initializer, and the semicolons kind of separate the 3 segments of a for loop. So we see a semicolon here and we see a semicolon here. And we see this first chunk is important, and this is our initializer. And then we see the second chunk here. This is our condition. And then this last piece is our final expression. And we'll talk a bit more about exactly what those do and what those mean. So the initializer might look familiar, this right here. It is actually a variable assignment. And we are assigning a variable to a number. So, let is how we assign variables. So we're saying let the variable I be assigned to the value of the number 1. So we are just assigning a variable I equal 1 here. And then we're ending that little statement, ending our initializer statement. And what this means is this first piece tells us where the loop should start. So what is our iteration, and that's usually why we use I here, is because this is representative of iteration. So we say, okay, we're starting this loop at the number 1, and we're going all the way to 100. So if we were to change this, for example, to 50, then our loop would start at 50 and then go up to 100. So we're actually only going to get 50 console logs for this. So here you'll see we started at 50 because we set let I equal 50, and then we go all the way up to 100. And if we started it at 0, we will actually get 101. So we go to 100, but we didn't start at 1, we started at 0. So we get 101 printed out. So that's how that first statement works, is this is our initializer. Like, where do we start from the beginning of our for loop? Okay. And next we have up our condition. So I is less than or equal to 100. And remember, I is just a variable. So this isn't anything super fancy as far as, JavaScript we haven't learned yet. This is just checking the value of this variable here to see if it is less than or equal to 100. And the way that I changes is with our final expression. So this piece here, the last chunk in our for loop, this runs after each iteration of the code. So when we do this code block, whenever this code block is run, so we say, let's start at 1. And as long as I is less than 100, we say, okay, cool. I is currently 1. If this is our first iteration, I is less than 100. So we're going to go ahead and run the code. So then from this point, then the code is run. This block is run. And then the final expression, even though it comes before this console log here, the final expression is evaluated after the code in the block has run. So now that the code ran, and that's why it's called the final, oh my goodness, that's why it's called the final expression. So after this happens, then we are going to do I++. So it's almost like that is, hold on, I can't, trying to do oh, there we go. So it's almost like this. Oh my gosh. Okay, it's almost like it's happening in this order. So, let I equal 1, as long as I is less than 100, console log I, then I++. That's like, if you were to read it in English, kind of how it looks like that's happening. So this guy here, what a plus plus does, this is also some new syntax. This is equivalent to saying that I equals I plus 1. So this is just a longer way of saying that I++. It's just an incrementer is what it's called. And this right here is also an incrementer. It's just a longer syntax, and it's much shorter and easier. If you're only adding 1, then you can just do I++. You can also do minus minus, which will decrement, or I don't know if I'm saying that right, decrement by 1. So we'll do I++, that's going to add 1 to the variable I at the end of each iteration of the loop. So we do a quick console log, and then we take our variable I and we add 1 to it. Then we start all over again, as long as I is less than 100. So we go back to the beginning, we say I now equals 2 because we incremented it here. And then is I less than or equal to 100? 2 is less than or equal to 100. So yes, we run the code again, then we increment it again. And that just happens over and over again until the incrementing gets it to 100 or 101. And then as soon as this hits 101, the I variable, then we go over here, we say, okay, let I, or sorry, not let I equal 1, but we go over here and we check it. And we say, okay, is it less than or equal to 100? And it's not. This is no longer true. This becomes false when 100, or when I equals 101. So at that point, the loop is done. And then any code beneath it will continue to execute, and the loop is over. So that's really the way that a loop works. And it may be easier here to make some changes and say, let's call this counter instead of I, so that we can kind of look at this with some different variables with a little bit of a different perspective. So we're going to call it counter now. So let counter equal 1. Counter is less than or equal to 100. Counter plus plus. And let's actually do this. Let's just make this 3. Let's make this real short. And we're going to console log. Let's do a little string concatenation in here. So we'll say iteration. We'll say, we'll call loop number, and then we will stick this guy in there. I is not defined. Oh, forgot to change this guy to counter. Okay. So this is pretty much what we were doing before. We just shortened it so that it's only going to run 3 times because we said as long as counter is less than or equal to 3, and we changed the variable I to the variable counter. It's a lot longer and a little uglier to read, especially when it's scrunched together like this, but it's doing the exact same thing. So we see loop number 1, loop number 2, and loop number 3. So we can see what's going on in here now, and when we use this counter variable. Sweet. Great. So we talked about the final expression, talked about shorthand. Yeah, and I guess I didn't mention this before, but counter plus plus here, even though this is a really short syntax, this is actually a variable reassignment. Because remember how we said that that's the same as saying counter equals counter plus 1. Which this right here, this is a variable reassignment because we are reassigning the value of the variable counter to itself plus the number 1. So I++ here is a variable reassignment, and then we go back in here into the loop at the beginning. Once we iterate the next time, and we see that the counter has changed. Cool. And I don't know why I've been on such a food kick lately, but all of my examples are cereal and donuts and food and buffets. Don't know why. Okay, sweet. So we created a fresh for loop to gain some more perspective. We already did that with counter. We said the loop has run X amount of times with some different, the old school string concatenation there. Now instead of I, we were using counter. Yes, yes. All right, cool. So now let's get into some of the real extendable usefulness of loops. So even now, even though we were able to do some very repetitive work quickly by using a loop, we're still a little bit tied down statically to the length of time that this loop runs. So when we set this, when we write this, and let's actually go back to our original small one for just for conciseness, this loop is only going to run 100 times ever. This will always run 100 times because this number 100 in here is hard coded into the loop. This can't change depending on user input or anything like that. It's just going to run this set amount of times every single time, which is fine if that's what we need. But sometimes it's helpful if we're iterating over a group of something, which, like we learned last week, it is an array, for example. An array is a great example of a group of items that you might want to do the same task on as you go through it. You want to say, okay, I want to add 2 to every single item in this array. That's when you would definitely use a loop. And loops are built to work nicely with arrays. Cool. So our loops thus far have only been set to run a specific number of times and to do some simple console operations. But what about looping over an unknown number of items? That's where arrays come in. And I don't know if I mentioned this before, but when we talk about iteration is basically just doing something again. Just looping and iteration are kind of synonymous. There's a little bit of difference, but for now, it's okay to just think of those as the same thing. Iteration is just, how many times you're doing something over and over again. Alrighty. So when we're talking about iterating over arrays, that's just a term meaning we're using a loop to do something as many times as there are things in the array. So arrays have indexes, which is really, really important to using a for loop or using a loop on it. So if we have an array here, let's create one and let's call it, let's put 1, let's put 2, let's put 5, and let's put a string in there. Okay. And if we do .length, we can find out how long it is. And if we use the index operator to look up something in here, if we wanted to get 2 out of here, we could put 1 in, right? Because this is going to grab something at the index of 1. And remember, arrays have a 0-based index. So this is index 0, this is index 1, this is index 2, and this is index 3. Even though the length is 4, this array ends at index 3. So if we wanted the second item, we'd put 1 in there. And if we wanted the first item, we would put 0 in there. That gives us this item back. So let's go ahead and assign that to a variable. And feel free to follow along with this if you'd like. So let's call this array. And we're going to do array equals, we'll just copy and paste this in. Okay. So those are our array. And now we're going to want to do a loop to loop over this and print out each item in the array to the console. So to do that, we're going to do our for loop. So we're going to do for, and we can even break it out and just kind of create the whole syntax at the beginning. And one quick pointer, if you are in the dev tools here and you're wanting to do a multi-line statement as you're writing your JavaScript, if you hit enter without any modifier, it will say uncaught or unexpected token for a syntax error. But what you can do, let's see if we go in here, setting up our for loop again, is if you hold shift down, shift will allow you to hit enter, and then it will not execute that code. So we can actually do multi-line statements directly in the console by holding shift down without running it. Cool. So we are going to say let I equal 0. Now, this is important because this is our initializer, and we want to start at the same point that our array starts. If we were to say let I equal 1, that would mean we are starting our loop at the second item in the array because the array has a 0-based index. So we want to start with 1. We don't want to start with 2. So if we want to start with this first item here, then we need to start our variable here at 1 so that our loop starts at the same point that the array starts. Okay, so we have that. And then the next statement is to say how long we want this loop to run. And we actually want this loop to run as long as the array is long. So we want to say, okay, as long as I is less than or equal to, and I think we just say less than here. So as long as I is less than the array dot length. So array dot length gives us 4. So we say, let's run this 4 times because that's how long the array is. Now already in this small for loop here, we've already created some more dynamic functionality to it by adding this array dot length here in what we check for how many times we should run this loop based off of its condition. So this condition is now dynamic. So if the array changes based off of user input or some other programmatic piece that we've added that pushes things into this array or removes them, then our loop will always adjust to run as many times as it needs to for how long the array is. Cool. And then lastly, we are going to do our I++. Now, this one doesn't really change very much. Usually, you're almost always going to be putting I++ as the third parameter in your for loop because you're usually just iterating up. One exception to this is you could iterate backwards, and start with the length of an array. Like you could even say let I equals array.length. And then, say as long as I is greater than 0, and then I minus minus, that would actually iterate backwards over the array. Rather than starting at 0, it would start at the very last item in the array. There are some use cases where that's helpful, but for now, and 90% of the time, you're always just going to be incrementing this up. Cool. So now let's go ahead and test this out and do a console.log of our item. So this right here, and sorry, I said console our item. We're actually not going to be console logging our item here. So this is still just going to log out 0, 1, 2, 3. The reason is because we are logging out our variable I, which just starts at 0, and then it just gets incremented. This actually doesn't log any value from the array. So if we wanted to log the value from the array, we could use this I variable here to access the array. And remember how we're starting with 0? So because we're starting at 0, the reason we chose that is so that it lines up with the index of the array, which means that we can actually use the index syntax to grab an item from the array by using our iterator variable, if that makes sense. Hopefully that's not too much. So if we go array I, and let's also go ahead and console log I by itself, just so we can see what it is as we go here. So let's run this. Okay, so we got 0, 1, 1, 2, 2, 6, 3. Perfect. Okay, this is, sorry, I'm gonna change what array is because that is extra confusing. That confused me. I thought that didn't work for a second. Okay, so we have array set to 1, 2, 6, and hello. And those numbers are actually making this extra confusing. So I'm going to go ahead and change this to all strings. So hello, there, Colin, and Michael. Okay, cool. So now our array is all strings. That'll make this a little easier to read. Okay, cool. And I guess this kind of works out in our favor here because you notice how we didn't have to change this for loop at all, and it's still going to work on this array, even though we changed it. So that is a testament to kind of the dynamic nature of this. So let's go ahead and run this now. Okay, so we got hello, there, Colin, and Michael. So we actually console logged out each individual item from that array by using our loop here. And by using the loop in conjunction with the index, because we set that variable let I equal 0 to start at the beginning index. And we can see that here because we have console log I, and then we have console log array I. So we see I0, and then array index of 0 is hello, sweet. And then we have 1, array index of 1 is there. And then we say, okay, cool. How about 2, Colin? Array index of 2 is Colin. Array index of 3 is and, array index of 4 is Michael. So we can see how this is working. And this is the like a very, very common way to leverage variables and indexes and loops all together in just a really cool, clever way to access values inside of an array. It's a really elegant way that these three things work together in tandem. Cool. So hopefully that makes sense. Colin, do you have any questions?
No.
Any questions you think other people might have? Let me know if any of that was confusing or.
I don't think so.
Okay.
Yeah, if I think of something, I'll let you know.
Sounds good. Okie doke. So we looped over arrays. Oh, I was supposed to use the serial examples. I forgot. That's okay. So arrays have indexes that point to each item. This is pretty much going over everything we just talked about, and loop iteration or initializers and counters to navigate arrays lightning fast, just like we did here. Cool, cool. Alrighty. So next up, we're going to talk about something. There's a way you can exit out of a loop, which is really cool. So in our for loops, we may want to exit out of the loop early, depending on the situation. So we can do this with the break statement. Let's say we wanted to have a function that we could pass a string and an array to, and we'll return true or false depending on if the string is contained inside of the array. So basically a search function. So let's go ahead and do this. Let's use this example. So first up, we're going to assign a variable, let my cereal, and we're going to assign it to an array of strings. Great. So we say my cereals. We get some Cheerios, some Fruit Loops, some Grape Nuts, some Apple Jacks. Awesome. Now we have a function here assigned to a constant variable. So I'm going to copy this whole chunk and place this in here. So let's break this down a little bit. What does this do? Constant find an array. So we have a constant variable that is assigned to a function. Now this function takes in two parameters, takes in a string and it takes in an array. And the reason we know that is just because of how these parameters are named. This could be named some gobbledygook, but we decided to name it string because that's indicative of what this should accept. So we're going to pass it in a string and an array, two parameters. And then inside of here, we are going to do a loop. We're going to iterate over the array. So we're saying, okay, for I equals 0, so we're starting at 0. So now we're saying some familiar syntax to our for loop. We're going to say as long as I is less than array.length, I++, increment. Great. And now inside of our for loop, instead of just doing that regular old console log, we're actually using an if statement here. So we actually have a conditional added in, which is cool. So we're using some extra pieces of logic that we've learned before. So in this conditional, we are checking to see if the index, if the item at this certain index of the array that we're at, so Ri, if it equals a string, then we say console log found the string at index blah. Cool. Now this is a little confusing. I'm actually going to change this name to search item instead of string because that is confusing. Okay. So if the item at the certain index of the array is exactly the same as the search item, as this string that was passed in, then that means we found what we were looking for. Hopefully that makes sense. So console.log found the string at index blank break. Now, this may be a bit of a complex example just to talk about the break statement here, but what we're doing now is we say, if we do find this, then break is going to stop our iteration altogether. So remember how here we do I++, and then we keep iterating as long as I is less than array.length. So what the break statement does basically is it says, forget this, it's over. Just cancel this iteration because it's done. You don't need to check this statement anymore. You don't need to evaluate whether or not I is less than array.length. I'm telling you now that we're done. Go ahead and stop looping. So this break statement just kills everything and breaks us out. So let's go ahead and create this array, or sorry, create this function here. So we now have our find in array function available to us, and it tells us what it is and what it takes. Now, to use it, what we'll have to do is we actually need to call it and pass in the right arguments. So what we're going to do is we're calling find in array. Remember, we're invoking the function here, so we're invoking it inside of these parentheses. And the first parameter we're passing, the first argument we're passing in is Cheerios, a string of Cheerios. And then the second argument is the array itself. And remember, up here we created that. So we said let my cereals equals this array. So we're passing in the array here, and we're looking for Cheerios. So we know by looking at this, the Cheerios is at the first index. So let's see if that works correctly. So we're running this function, find an array. String is not defined. Oh, I see. Sorry. So this is now go find an array. Go find an array Cheerios. My cereal is getting passed in. Okay. So we actually got something returned, or a console log that said found the Cheerios at index of 0, which is sweet. That's true. We do have our Cheerios at index of 0 here because it found it and then it didn't continue on here. And we can actually test this. If we add, let's update our function a little bit here, because we don't know if this continued iterating or not. Because we're not actually doing any other stuff in here. So inside of this if statement, we're saying if it equals that, then break out. And gosh darn it, sorry. Let's do another console log right after that that conditional. And let's say hello. Cool, that'll work. Okay, sorry, this is getting confusing now. Just going to look at that so we can keep an eye on our function. And now we're going to call it again. Okie dokie, now we're getting there. Okay, sweet. Hello, found the Fruit Loops at index 1. So let's really break down and see an example of how our break statement is working here by doing the same thing without the break statement. Okay, so we redefined our function and we're going to look for the same thing here. So now we're going to do the exact same thing. Okay, there we go. Okay, sweet. So when I remove the break statement, we actually get hello printed out 3 times, or 4 times, sorry, because it doesn't stop. So when it finds the item, it still iterates again because there's nothing telling it to stop because it hasn't satisfied that statement I is less than array.length because it's not reaching that end statement until it's gone through every single item, where the break statement allows us to say, "Ooh, cool, we found what we were looking for. Let's go ahead and break out." So if we adjust the function and we add that break statement back in before this console log here, or sorry, if we add the break statement inside of the if block to say, if this is found, then break out. So then when we run this again, remember last time we found, so it printed hello, found the Fruit Loops, and then hello 3 more times. So it didn't stop when it found the Fruit Loops. So let's see if we get a different output this time around. Okay, so we see we got the first hello because it went through and Fruit Loops is the second item in the array. and then we didn't get all of those hellos printed out. So last time I printed 3, but then this time it didn't at all, which means that our break statement is working because it's stopping this whole iteration as soon as it satisfies, or as soon as it enters this if block here, because we did find this search item. We console logged it, and then we broke out, which is great. So we can use a break statement to stop our loops. That was a contrived, well, not contrived, but that was a little bit of an overcomplicated example. So I apologize for that. That was kind of mixing a lot of different pieces together. But this is an example of how a break statement can be used. It just stops the loop. Okay. And we're breaking this down a little bit. We put our for loop inside of a function. This allows us to pass in different parameters each time we call the function and execute the loop. Here, array is the same as my serials because we pass my serials to this function as the second argument. So here we pass it in as an argument. Here we are using our break statement. Cool. So this is just breaking down kind of what we did here. So this might make it a little clearer. To check that our break statement is working, we can put another console.log at the beginning of our loop. Great. So that's what we did. Maybe this is a little clearer. Alrighty. Okay, so let's look carefully at the indexes that are printed before the string. When we search for Cheerios, it only printed index 0 because it found what we were looking for, and then the break statement prevented the loop from running again. So try running this without the break and see what happens. And that's where we got all of these hellos printed out, for example. Okay, cool. So that's how the break statement can help us out and help us stop looping. So next up, we're going to talk about infinite loops. So one of the most important concepts of looping and iteration is that there needs to be an end goal that the loop will eventually reach. If a loop can never reach its end goal, then you will end up with something called an infinite loop. Infinite loops are a death sentence for your program. And you will definitely know when you have written one on accident, because it will never stop and it will consume as much CPU power as your computer will offer. And you'll start hearing those fans running and you'll realize that you did something wrong and your browser tab will stop working. Okay, so here's our first for loop example we looked at right here. So focus on the condition of the loop. And remember, the condition is the second item inside of the parentheses. So the condition is I is less than or equal to 100. So as long as this evaluates to true, the loop will run. As soon as this evaluates to false, the loop stops running. And every time that we increment here with our last statement, our final statement, this brings us one step closer to this no longer being true, because we are getting closer to 100 from 1. We're just counting up. And this is what prevents our loop from being infinite, is basically the way that these interact together, saying we're starting at 1, we're counting up every time, and as long as we're less than or equal to 100. If we change this to 1,000,000, it's still not an infinite loop because 1 will eventually reach 1,000,000. And it's just going to count from 1 to 1,000,000. So what about this one? What about this loop? You see any subtle differences here between this guy? If we're focusing on the condition of this loop, we see that instead of saying, as long as I is less than or equal to something, we don't have any kind of evaluation here. We're just saying true. We're just passing true in for this. So if this is our condition, this means that this will always run, because this condition can never become false. It's just set to true. So let I equal 1. So we're starting at 1. And as long as true is true, then I plus plus. And as far as everything I know, true is always going to stay true. And we're going to continue incrementing this guy up. And then we're going to console log I times 1,000. So Colin, do you want to copy and paste this into your browser?
Well, you want me to be the guinea pig?
You're the only guinea pig.
Computer's already like slow.
I know, exactly. It's going to destroy it. Throw it in there and see what happens. Let's see if we can get those fans, crank it up. You can always just put it in a new browser tab. You can just kill. That loop will never end because the condition will always be true. There is no endpoint for our loop. Even though we are incrementing our initializer, it doesn't matter because the condition is simply set to true. When you write infinite loops, be careful to make sure, when you write loops, don't write infinite loops. When you write loops, be careful to make sure that they have a stopping point. And if you did run that in your browser, you can close the tab and it should kill the loop. If that doesn't work, you can just close the whole browser and that will definitely kill the loop. Since all this code is JavaScript and it's just running in your browser, it's not going to actually ruin your computer. It's just the browser running out of space, running out of memory. Did you get it going, Colin?
Not yet. It's taken for. I've got that thing going in the background already, so it's taking a minute to open a new
Oh
tab.
no, yeah. Oh wait, so you haven't even opened a new tab yet? Oh boy,
I got it open now.
your whole computer is an infinite loop.
I know. Oh
Okay,
God.
well you're still doing that.
Here we go.
Okay, you're pasting it. How's she doing?
Oh God. Now I'm trying to exit out.
Is it still going?
It's still going.
Is it already slowing everything down, or can you even tell since your computer's already so slow?
Yeah, my fan's going a lot higher now. Oh boy.
It's
Close.
cranking out.
There we go. Oh, thank God.
I love it. All right, thanks, Colin, for doing that. It's fun.
You're welcome.
All right, the homework for loops is a simple game that will draw on what we've learned from the DOM, functions, variables, arrays, and loops. So don't forget to pull up the lesson plans as you go along if you need a refresher. This homework is a simple game, but as far as the logic and the pieces that we're using, this is probably the most complex one so far. There's a lot going on, and we're going to have multiple tiers of difficulty. So we're going to have an easy, a medium, and a hard, basically. And what that's going to equate to is that the easy mode has a lot more code written for you. So there'll be much more guidance as to what you need to add and where you need to add it. And it will still allow you to practice looping and iteration in particular, but some of the functions will already be defined and you'll just have to add code inside of them. So then the medium is going to have a little bit less. So you'll have to actually write some of the functions, you'll have to define more, come up with kind of the structure of how you want to do it yourself. And then the hard mode is really just going to be no starter code. It's just going to be guidance as to what you need to write, what code you need to write, the steps to take. And then we may do even an extra hard mode that's basically a simple statement as to what the program should do, and then you have to come up with all of it yourself. So I kind of recommend, if possible, to start, if you're feeling uncomfortable, to just start with the easy mode and get it done. And then maybe after a couple more lessons and you're a little further along, maybe come back to this and try to do one of the harder versions of it, and kind of refresh your memory and try writing more code from scratch. Could be helpful. Might really drive it home. Cool. So it's called Gamblin Grannie, and we are going to fork the Gamblin Grannie repository. So you're going to go ahead and click fork, and then you're going to clone it down. And all of the instructions for the homework are inside of the app.js file in the Gamblin Grannie repository. So in here, as soon as you clone this down to your own, you're going to have this app.js function or app.js file, and this is going to have right now it has the actual code itself, so no spoilers. But as soon as I push up the actual steps, where a lot of this is going to be removed, and you're going to have to write that and add that in yourself. So app.js is where you're going to follow along. So let's look at the example really quickly. So here's an example of the finished game. So this is Gamblin Grannie. So Granny's in Vegas. She's got some money down here. She has some luck. Got a little fork me button. Got our header. And then we have this little pixel art. I did not do any of this pixel art. We'll have to credit all the artists that did this work. I just found this stuff on Google. But you'll click this to pull the lever, and then the numbers start spinning. These are just GIF images, so you don't have to worry about animations or anything here. So these start spinning, and as soon as we pulled the lever, we lost a coin because Granny gambled a coin. And then you'll click on these buttons, these numbers, to stop them. So we got a 4, we got a 1, and we got a 1. Okay, so we lost. So we didn't get anything. So we pull it again, we gamble another coin, and then the numbers spin, and we do this. Oh, that was close, but nope. Now, you can also change your luck. So if we want to be more lucky, we'll click lucky here. And what this is going to do basically is these numbers are, each of these guys are an array. And in these arrays, we are basically saying how long the array should be. And if it's unlucky, then it's 0 to 10 or 0 to 9. If it's neutral, it's 0 to 6. And if it's lucky, it's 0 to 3. So now there's just a lot less numbers for this to go through. So we're never going to go over 3 here. So 1, 2, 2, 2, 0, 1, nope. Okay, so even the lucky one is still kind of hard to hit sometimes. Close. And then down here, the lucky, neutral, and unlucky, yeah, these radio buttons have values attached to them, and then these values are used to set the length of the arrays here and how difficult these numbers should be to stop. And then down here, this is also an array. So this is an array that contains all these coins, and we're iterating over that to then append the single image of a coin to the DOM. There's only one of these pictures included in the repository, and it's just looping over how many there should be here. And we start out with 10. So if we refresh the page, you'll see that there's 10 that get added in. We're just looping to see how many we need to add. And then as soon as you hit a jackpot, which let's see if we can get there, it will add more. It will loop over how many numbers the jackpot is set to, and then it will automatically add those into the DOM here. All right, let's see if we can get a jackpot. Oh man, this is gonna take forever. Oh, so close. Gamblin Grannie. There we go. So when you hit the jackpot, you get your money added down here at the bottom, and it shows you a jackpot. This is just that's just something hidden and displayed depending on the state of the game. So if you pull the lever a bunch, she keeps gambling even without stopping it. And if Grannie runs out of money, the last time she pulls it, we get a little alert. It says, I think it's time to go home. Cool. We can also make that part of the cool, little 8-bit font if you want to, rather than an alert. So this is the game. Hopefully it's something you can alter and change and mix up and make it your own, or add different features to it if you want, or add animations. So this is what we're going to do.